Alright, so this is the next segment of our video virtualization videos, and we are covering XEN at the moment. Uh, I'm going to create a new virtual machine, and this time it's going to be a hardware assisted virtual machine. To make things easier, I have created this kickstart with the help of this test VM. I used its anaconda case.cfg, which is created by default after the successful install. So I used all the same things, same settings, just copied, pasted them here, changed this to text to make it more faster and so that it doesn't use graphics. This is the install URL. This is correct. Ethernet 0 DHCP. Hostname is going to be test virtual machine 2. The rest of the things I'm going to leave as it is, except that I've uncommented clear partition Linux. To be precise, it should be clear part all. It should be clear part all, but anyway. And partition root is going to be this much size, and that's all. So this file should be readable by at least Apache web server, so it is readable. So I'm going to create this file, so I don't have to I'm going to create this now virtual machine, new, next, and I believe it's going to give me the same problem. This is going to be test-vm2 forward. It's going to be full virtualized, and I'm going to give it this CPU architecture. Only these two right now are supported, and hypervisor is XEN. I'm not running KVM right now. Remember, I'm running this kernel which is kernel XEN on my physical host, so it will not show you KVM here, so only XEN is showing up. Next, I can use local install media, and this time surprisingly this network install tree is disabled. This is first time I'm experiencing this. Anyhow, local media, I have already a DVD as I showed you earlier, so let's select OS type Linux and Red Hat 5. Next, CD location, ISO image location. It's in root, data, CD images, sent OS 5.4. Fine. I've got a bad throat, so just excuse me for that. Okay, file is going to be located. This path is okay. This path is okay. I'm going to give it like 2. No, I'm going to give it 2 GB of disk only. How much I've got left now? Let's check first. Okay, I still have 6 GB here, so that shouldn't be any problem. 2 GB, I don't know if it will work or not, but let's see. I'm going to give it virtual network, which is going to be the private network, of course, forward, and I'm going to give it 512 MB is enough. 2 CPUs, let's give 2 CPUs while we can, and press forward. So this is how it's going to be, and unfortunately it's not going to ask me for the kickstart location, which I'm disappointed to see, but anyway, let's quickly finish. Okay, so a 2 GB file is being created, which will act as the disk for this virtual machine. Come on. Okay, this is the install screen. I clicked inside, and I hope I can use a trick, which is, first let me click this full screen. Okay, so the trick is Linux text and ks is equal to http://192.168.122.1/ what was the name? Let me see. Test.ks, if I'm correct. That should be it. Yeah, okay, let's try. Press enter. So hopefully I can still use my kickstart. Let's see what happens now. Excuse me for my cough, bad throat. Oh great, it's already requesting for IP and getting all the media. Oh lovely. This shouldn't take more than few minutes, so okay, yes, go on. Any answer which is not found inside the kickstart is asked interactively. Rest of the things are being done automatically. Okay, lovely, very good. Okay, this is sometimes the installation fails here if the size of the disk is too small. Okay, it's past that stage. Great. So I can get away with 2 GB size disks. Okay, that should be okay. And if I look at the while this continues, we'll look at the usage graph here, and you'll see this domain, this test2 is currently using about 44% of CPU, and our test VM1 is also running. So we've got like main domain 0 running, then we've got this system already running, and we've got this second system also being installed. So we've got 3 systems online. 2 of them are virtual, pure virtual you can say, and one domain 0 is also virtual, but it's the management domain you can say. Still, for in general terms, we've got 3 systems connected to each other right now. Okay, so this seems to be slow. I don't know, maybe I'm mistaken. Alright, so 5 more minutes. So what I'll do is I won't waste your 5 minutes or so. I'll stop this. If I stop this, I have to start off with a new window, a new video. Okay, let me show other interesting stuff to you. Let me see if I have something here. Okay, XEN. Did I cover this? What is XEN? Yes, I did. Okay, this another interesting presentation by this gentleman. High availability data center on a laptop with XEN, and how you are going to go about it is shown here by these 2 guys, Det and Send and Emir M Spile or Spiel. uh, okay, so they are going to do all of this stuff in high availability mode. This is XEN architecture covered in yet another diagram, quite helpful. You've got your hardware here, your XEN hypervisor here, domain 0 here, and domain U here. Okay, this is one of the diagrams which I was looking for earlier. This is your Ethernet 0, but it's kind of overwritten for some reason, I don't know. This is your Ethernet 0, and it's also WBITT 0. That is why it's kind of overwritten. And this is your physical Ethernet 0, here. This is XEN bridge, this dotted line inside, and the domain 0 is connected through this ETA 0 to your XEN bridge through this virtual interface 0.0. And since this whole thing is a switch, so naturally the traffic from this place goes to this place and then connects here, physical Ethernet 0, and then goes out on your network here. And any domain U is connected to this virtual interface x.0 connected to domain x.0 here, connected to XEN bridge again. And this was bridging, this is also bridging. This is the same diagram, a bit clear. Yeah, this is the same diagram. Okay, here he's creating a sample scenario, that Oracle rack node 1, node 2, and shared storage, and how he would go about doing everything, how he would create this real Oracle rack real application cluster, how he would create iSCSI devices. It's an interesting document. It's quite interesting document. It's worth to read it at least once. Okay, great document. You have to find it. I don't know that. Let me show you the title again. High availability data center on Linux, on laptop or desktop with XEN, of course. Close this. Let's check up our this guy. Still 1 minute left, so time to show more things. iSCSI XEN cluster. Okay, this is also something important. If you are wondering that why I've got all of these iSCSI stuff here and here, what have I got to do with it? The thing is that I get kind of support calls, or kind of at times help calls from my friends, from my past company, or from here and there, who are Oracle DBAs, and they're experimenting with RAG. So I kind of try to experiment with Oracle RAG myself as well. Although I've got a love-hate relationship with Oracle, but still I get to do this dirty stuff. Let's see here. Still left. Okay. What we'll try next is we'll put a Windows CD and try to install a Windows OS on this on XEN in a later stage. I might do it now, I might do it maybe tomorrow, day after tomorrow. It's not, I don't know yet, because it's already 9 o'clock in the night and I've got to wake up at 6 to reach my office at 7. It's really strange, funny timings here. Okay, so let's say full screen. and see what's happening here. Installing bootloader, great. Okay, reboot. Congratulations, fine. So press reboot. Come on, or do I have to start you manually? Come on, run. Okay, so this is the Grub bootloader, normal Grub bootloader, which you will not see in para-virtualized machines. They will just boot off straight away from Python Grub, which is something we'll cover later. But I've pressed escape here and press E, and you can pass all sorts of parameters here if you want to. So let's press B for boot and let it boot for now. See, it's got P2 this time. This is emulation, kind of, if I'm correct. I can already feel that it's slow. I don't know, it's psychological or it's reality, I don't know. I feel it's quite slow, although it's the same machine we've just used for para-virtual machine, the same CentOS machine. Oh, I was probably showing you something interesting. Where did it go? Or I've already shown you iSCSI. Okay, yeah, I did not show you this. It's a tutorial from Linux Congress 2008, Hamburg, Germany, and it's created by Thomas Grub, if I'm correct in pronunciating his name. TG or TG or okay, Chemnitz. Okay, so they've got this beautiful document here explaining how they have set up this whole thing on iSCSI, how many servers they've used. Cluster consists of a couple of cluster servers, minimum 2. iSCSI storage, interesting stuff. High availability, DRBT, they're also using DRBT. Okay, great. And this is LAX. Is it cluster manager software? I've heard of its name somewhere. Yeah, probably. Okay, so this is what they're doing. 2 physical hosts here, 1 physical host here acting as storage, and Gbit switch in between, all that stuff. Open SSH auto login, yeah, true. Okay, so this is again another interesting stuff, another interesting document. So let me show you the title here so you can search for it on the internet. Building a virtualization cluster based on XEN and iSCSI SAN. Fine, let's check up on our virtual machine again. Okay, luckily it's logged in already. Not logged in, at least showing the terminal part. It's CentOS 5.4 alright on x86-64. Okay, so this mouse synchronization is okay. Let's click full screen. Okay, come on, don't mess with me, you mouse. Okay, root. I don't have to do anything with mouse here. Root Red Hat is my password. Okay, VM2 is installed, and if I check df-h, it shows me that it has used about 900 megabytes. And check the kernel. See, it's a normal kernel. Check the IP. IP would be like, okay, it's 19. IP has nothing to do with it. There is a small difference if I'm correct in noticing. Let me connect to this machine here. SSH root at 192.168.122.19. Yes, Red Hat is the password. Okay, oh come on. Okay, the difference which I wanted to show you is ifconfig Ethernet 0, and this is test VM1, and ifconfig, come on, what's wrong? ifconfig Ethernet 0. Okay, no, I'm not. Okay, the difference is not there. Basically what I was trying to notice is if the MAC address is of a different range, you will see a different range here. A different first 3 octets would be different when you will use KVM. When you will use KVM virtualization, you will see difference here. So right now both of these machines, one of them is paravirtual. This test VM1 is paravirtual. It has got the MAC address of the same here. This 01636, and test 2 VM2 is also 01636 MAC address family. Let's check its processor. less/proc/CPU info. Okay, it's got the same processor, luckily. I don't know why it's kind of slow. 3 GHz, same processor. Okay, same processor. LSPCI shows some information here, and LSPCI does not show any information on paravirtual machine. See, it just throws out this empty null output, because in paravirtual machine, as I explained during the first few videos, no hardware is emulated. Everything runs on the same hardware. That's why everything runs extremely fast. Here you see that some parts of the hardware were emulated, like Intel. This is the host bridge, probably this is the motherboard, is emulated 440FX, and it is documented. ISA bridge, IDE interface, USB controller is also emulated, VGA compatible controller is also emulated, Ethernet controller is emulated as Realtek, which is quite slow for production environments. Realtek, we never use Realtek for production environments, and even if you use it in virtualization setups, there is a trick to use enhanced versions of enhanced drivers, network drivers, but we'll cover that later. Right now I just wanted to show you that how a paravirtual machine would look like, and how a full hardware assisted virtual machine would look like. The working is of course the same. The kernel is different. You see, this kernel here is a normal kernel, whereas a paravirtual machine is running a normal kernel. I can go ahead and install probably a foolish thing you would say to do on Linux, like installing Windows on a virtual machine, but for the sake of experiment we'll try to do that, running Windows under this as HVM machine, and we'll see whether we can do it or not. Let's quickly check before I close this or finish this video. Quickly check the configuration files. Cat test VM1. This is how a paravirtual machine's configuration look like in XEN. And let's see test VM2. Oh, it's got so much stuff in it. It's got this name, this UID, memory. That's understandable. Builder is changed. Builder is specifically mentioned as HVM, which is not here on the top in the first machine. This is the kernel, boot, physical address extension is available, ACPI, APIC. These are extra flags which are being passed. Device model is QEMU, device model QEMU. I discussed this in the beginning earlier videos, what QEMU is and what is its significance. And what else we've got here? This is the disk. I suppose there's a difference of disk as well. This is file and it's labeled as HDA, whereas in the para virtual machine the disk is mentioned as TAP and is exported as XVDA. Okay, and you don't get to choose these names yourself. You can't just type super disk A or something. This is reserved naming scheme which you have to use, as far as I know. Maybe I'm wrong here, but as far as I know. This is CD-ROM, emulated CD-ROM, and this is serial interface. So let's quickly check the disk. This says that there's a disk name on this para virtual machine. There's a disk named /dev XVDA, 3 GB in size. And here fdisk -L would show me that there's a disk named dev HDA, size of 2 GB, and it has this partition layout. The partition layout is the same, means that should be the same, of course, no problem. The name of the disk is different, and naturally I believe that there would be a disk. If I do dmessage pipe through grep IDE, I would get this P2X3. This is what I noticed when it was booting up. So this is the IDE controller basically, and the hard drive is emulated to be connected on IDE 0 here. Okay, so since there's no CD in the HTC drive, so you get these errors here, but they're not errors, just warnings. Whereas you won't see, hopefully, let me check this IDE here. Nothing. Hard drive is not connected to IDE. It is connected directly to the XEN through XEN hypervisor directly to the hardware, and that's why this special device TAP means is there. It's not means, that's why it's there. Alright, so we conclude this here at the moment. For now, we've got how to we learned what virtualization is, we learned what benefits are of virtualization, we learned what XEN architecture is, we learned what network concepts are for XEN. We saw how we can install a virtual machine in para virtual mode, and how can we install a virtual machine in fully hardware assisted virtualization mode. That's all. We'll be playing a lot. Our playground is kind of ready now, so we'll be playing a lot on this whole thing. We'll be creating more virtual machines in different types of backend storage. We'll be moving them around through live migration and all that, and it will be fun, inshallah, God willing. So see you next time. Till that time, goodbye. Thank you for watching.